So hemoglobin has a heme prosthetic group, but this is a non-amino acid that's permanently associated with the protein. This is our O2 that is bound. And basically heme is constructed of a complex organic ring structure called protoporphyrin. I believe that's how it's spelled. So this is this complex ring structure that is mostly flat with some perpendicular bonds. There are 6 coordination bonds total for the heme. There are 4 nitrogen atoms in a flat ring that make up the porphyrin organic structure. Here's the 4 right here. And then you have 2 O2 bonds for which the O2 or the oxygen molecule will bind. In addition, this is another way to look at it. So the 4 nitrogen atoms bond equatorially, so you can just 1, 2, 3, 4 nitrogen atoms, and then that leaves 2 of the coordination bonds open. Because this is encased in a protein, it does make those coordination bonds more restrictive in access, which is a good thing because you just don't want it binding with anything, and also you don't want it to bind to other heme to make those dimers we were talking about earlier. So for one coordination bond, you're going to have a proximal histidine residue, and then the second coordination bond where your O2 is going to bind. So carbon monoxide can also bind to the heme. It is 200 to 300 times more strongly bounded than O2, at least the affinity is higher, which is why it's also a good thing that the heme is encased in this protein that can regulate what's getting inside to bind.